All right, so today's the first day of the second grading period, which means that we are going to start a new unit. First semester we did a lot of operation stuff, adding, subtracting, multiplying, dividing with different types of numbers. We did a lot of solving equations. This triad, we're going to talk a lot about square roots. And there's a lot to do with square roots. It's kind of a narrow topic, meaning that it's all going to be about square roots, or at least lead to square roots. But in the end, we're going to be able to simplify square roots, add, subtract, multiply, and divide square roots, and even solve some equations with square roots. So that's our goal by the end of the triad. The first thing we're going to do, though, to simplify square roots is going to involve this prime factorization, which we did a little bit of in the opener. So what I need you to do is help me out here with filling in the blanks. First of all, what is a composite number? So it's a number that can be divided into, well, smaller numbers. Okay, so it can be written as, well, smaller numbers being multiplied together. What do we call it when we multiply numbers together? What's the answer to a multiplication problem? Sum is the answer to an addition problem. What's the answer to a multiplication problem? What'd you say, Jasmine? Product, yeah. All right, so what this sentence right here is saying is every composite number can be written as the product, okay, meaning that we're going to multiply numbers together. So it can be written as the product of what? When we did the prime factorization, what kind of numbers did we multiply together to get those bigger numbers? What were those numbers that we circled? No, not odd. Prime numbers. All right, so every composite number can be written as the product of prime numbers. Now this is really important because it basically says that every number, whether it's prime or composite, is made up of prime numbers. Can be multiplied, or we can take prime numbers and multiply them together to get any number that we want. And this is going to be really important, especially when we're dealing with simplifying square roots, because we're going to want to deal with these prime numbers. All right, the second one method of finding the prime numbers in a composite number is by using a what? What did we use to find the prime numbers? Factor tree. All right, so one way of finding the prime numbers in a composite number is by using a factor tree. And the factor tree is an easy way to do it because we can just keep breaking down those composite numbers into smaller and smaller numbers until we get to the prime numbers. And eventually all of those numbers are going to become prime numbers. All right, and then the last thing that we're going to... that was the last one, wasn't it? We've got more later. All right, so let's do two prime factorizations together. I know we already did a couple. Let's start with one, kind of a big number, 120. This is not a number that you would be able to get help with in your multiplication chart, but there's a trick to this one. This one ends in a 0, right? So since it ends in a 0, what do I know about it? 10 goes into it, right? And another great thing about dividing by 10, first of all, if you don't know what you multiply by 10 to get 120, you could just divide 120 divided by 10. But how do I figure out what do we multiply by 10 to get 120? It's 12. Why? How do you know it's 12? Yeah, but how do we know that? Looking at this number right here, 120, how do we know if we divide by 10? Yeah, if we just cross off this 0 here, we're left with 12, right? So dividing by 10 essentially just knocks a 0 off the end. All right, so it's going to be 10 times 12. Now that we have 10 times 12, this is going to be pretty easy because these are numbers that we're familiar with. What do we multiply together to get 10? 5 times 2. Okay, are either of those composite? No, they're both prime, right? We can circle those because we're done. All right, and then how about 12? That would be 4 times 3. 3 is prime. But 4 we can keep going with. That would be 2 times 2. Alright, so this is a factor tree that gives us all of the prime factors of 120. So if you were to take your calculator, which you don't have to do it right now, but if you were, and you would type in 5 times 2 times 2 times 2 times 3. You multiply all these numbers together that we have circled, what are we going to get? 120. Alright, so that's what we were saying when it said every composite number can be written as the product of prime numbers. Well, the product of 5 times 2 times 2 times 2 times 3 is going to be 120. Alright, now, this is not how we're going to write our answer. We have to write our answer out in line, meaning that I'm going to write it out next to the 120 here. So I'm going to put an equal sign to show what I'm about to write here is going to be equal to 120.
Just to help make it easier.
Now what I'm going to do is I'm going to list them all out, and I'm going to write all those numbers multiplied together. But I'm going to do it in a very specific order. I want to do it in a way that every time I do it, and every time you do it, and every time anybody else does it, we always get an answer that looks exactly the same. So if I just write it in this order, 5 times 2 times 2 times 2 times 3, that order just came from the way I factored it. And I can factor it any way I want. So I don't want to write it in that order. Anybody know which order we're going to do? Malik? Yeah, so we're going to do the 2's first, and then the 3, and then... So what order are we going in? Least to greatest, right? So we're always going to write our prime factors least to greatest. And since we're multiplying them all together, we're going to multiply them. We're going to put a multiplication dot in between them. So we had 3 2's, so it's going to be 2 times 2 times 2 times 3 times 5. And this right here is what we call prime factorization. So if we take all those numbers and we multiply them all together, we're going to get 120. And those are all prime numbers. So let's look at another example then. We want to write the prime factorization of 19.
Whoa.
Now this one's a little different. Why is this one a little different?
Because it's
Yeah, 19 is a prime number. Can we factor it?
yeah.
No.
No.
The only way to factor it would be 19 times...
One time.
Yeah, don't do this, but I'm going to show you what happens here. And this is why we don't use 1 as a prime number. If we do 19 times 1, and then, so 19 then would be 19 times 1. But then we could factor this and say 19 times 1. And then we could keep going and say 19 times 1. And that would go on forever, right? So we don't really know when to stop. So we never use 1 as a prime number in our factorization because otherwise it would just keep going forever. And 19, we wouldn't really call 19 a prime number then because we could factor it using the 1. All right, so how do I write my answer?
Equals 1 times 19.
No. It's just going to be 19. Okay, we don't want to put 1 in there because when we say prime factorization, we want it to just be prime numbers. If we do 1 times 19, 1 is not a prime number. All right, so anytime you're asked to factor a number that's already prime, it's just that number by itself. That's it. One other thing here before we give you your homework. Exponential form is something that's going to make things a little easier for us. I want you to read through this here and see if you can figure out what's going to go in those blanks. I'll give you a second to do that. So when the factors of a number are repeated, kind of like when we did the 120, we had a few 2's in there. The prime factorization. All right, so that's what we're doing here, prime factorizations. The prime factorization can be written in, well, I gave this one away up here. Can be written in what? Exponential form. And what does exponential form mean? What is an exponent? Anybody tell me what an exponent is? So an exponent is a little number, like if you said maybe 3 to the 4th power, the exponent is the 4, right? What does that 4 tell me? It's 3 being multiplied by itself 4 times. So it's 3 repeated over and over again. So what we're saying here is when numbers are repeated, we can use exponential form. We can write things like this. And it does 2 things for us. It's going to save us some time. So that's the first part there. So it's going to save us some time, and it's going to make it easier to read in a lot of cases. And I'll show you why in a minute. All right, so instead of writing 3 times 3 times 3 times 3, I can just write 3 to the 4th power. Or let's say I had 14 3s in a row. So I wrote 3 to the 14th power. It would be really hard to look at this and just know right off the bat that there are 14 3s here, right? So this way is not only quicker, but it's easier to read because I see there's a bunch of 3s here, but I don't know exactly how many there are. Here I can look at this and right off the bat I know it's 14 3s being multiplied together. That would be a pretty big number, wouldn't it? Yeah, because 3 times 3 is 9, times 3 is 27, times 3 is 81. We're already at 81 and we've got a bunch more to go. So it's going to save us time. It's going to make it easier to read. So let's look at a few examples here. We're going to write things in what we call standard form, and we're going to write things in exponential form. We'll do. I want to use 288 as an example. If you factor 288, this is not your example. Don't write this down. If you factor 288, these are the numbers that would be your circled numbers, your prime numbers. So it would be 2 times 2 times 2 times 2 times 2 times 3 times 3. That's called standard form. Okay, we wrote them smallest numbers first, biggest numbers second. What would the exponential form look like? Crystal? Okay, it would be 2 to the 5th power times 3 to the 2nd power. So the exponential form is a lot shorter. And even with just a few 2's here, I have to still count them at 1, 2, 3, 4, 5 before I know it's 2 to the 5th power. All right, so this way it's going to make it easier to read because we don't have as many numbers written out there. Okay, so here are the examples that we're going to do. This is your first example. This is a prime factorization, but it's written in the wrong order. So the first thing I want you to do, write this out and then put an equal sign after it. And I want you to still write it in standard form. Don't use exponents yet, but put it in the right order. What's it going to look like in standard form? What's the correct order here? Somebody read it off for me. No. In the right order.
2 times 2 times
2 times 2 times 2
times 3
times 3
times 3
times 7. All right, so that's what's called standard form. So standard form is all the numbers written out, but smallest to biggest. Then the exponential form, you should have written another equal sign after that. I'm going to put it on the next line because I'm out of space. The exponential form is going to be using exponents. So what's that going to look like? 2 to the 3rd power.
2 to the 3rd power. Times 3 to the 2nd power.
Times 3 to the 2nd power.
Times 7.
Times 7. And what's the power on the 7? Okay. Does that 1 have to be there? No. 7 to the 1st power can be written like this with the 1 and the exponent, or you can leave it off. Either way. Usually when I'm doing exponential form, I'm going to put it on there just to show that there's 1 there, but you don't have to have it there. Moving on then. Same thing with this one. Write it in standard form first, meaning all of the numbers written out, except you need to make sure that you have them smallest to biggest. and then go ahead and write it in exponential form. All right, so standard form first. I don't have any space over here, so I'm going to go down to the next line, but you should be able to write it out in line. What's going to go first?
2 times 2 times 2.
2 times 2 times 2.
5 times 5 times 5 times 5.
There's 4 of them.
Yep.
5 times 5 times 5 times 5 times 11. Okay, and then our exponential form?
2 times 2 to the third
2 to the third power
times 5 to the fourth
times 5 to the fourth power times 11 to the first power. All right, again, with exponential form, I like to put an exponent on all of them. You don't have to put the 1 there, but I like to put it there just so we know that there's 111 there. Any questions about that one? Okay. How about this one? I'm going to tell you right now, there's a trick to this one. See if you can figure out what's going on here. So since 15 is not a prime number, we want to rewrite it, and this is going to be a 3 times 5 here. So let's go ahead and write standard form right off the bat. What's going to come first?
2.
Then what?
3.
Then what? Then what? Okay, so there's your standard form. And then exponential form is going to be what? 2 to the first times 3 to the first times 5 to the first. So does the exponential form really help us here? No. Since all of the factors just happen one time here, the exponential form isn't really any different. We could drop all these 1s off and it looks exactly the same as our standard form. All right, so sometimes exponential form helps when they're repeated. Usually they don't help. Well, I'm sorry, I shouldn't say usually, but sometimes they don't help though because we get something that looks like this.